Hola, hola, 1, 2. ¿Se oye? ¿Sí? Perfecto.
¿Hemos dicho inglés?
Sí, bueno, al menos eso decía Jorge.
Mira, voy a poner esto aquí y como te hacemos un zoom para grabarte cerca, muévete de aquí a aquí más o menos.
Vale.
O sea, con libertad, pero que no nos haga corretear.
Vale.
Te presento ¿vale? Y empieza.
Vale, perfecto.
En inglés hemos dicho.
Sí.
Well, hi everyone. Welcome to J2ME office and welcome to BlackBerry Android Developer Group. As you know, we are a meetup specific of Android, and we do every month. Welcome to the new faces. We are here in J2ME with this online travel agency. We are 4 brands, and we are hiring Android developers, iOS developers, and backenders. So feel free to come by us later, and we have a talk. Later we will have beers and pizza, so don't go directly after this amazing charla of Xavier. And that's it. Thank you very much for coming, and I let you with Xavier.
Hi. Thanks, Andres. Hi, everybody. So, 1 second. Let me switch. So, today we will see how to create custom controls on Android and how to use Canvas to do it. We will see mainly 2 ways of creating custom controls. The easy one, let's call it, and the more complex one. So basically, what we can do with this is to create controls that don't exist on Android or that we want to be customized for our application. We can do it in many ways. We can use theming, we can use other techniques, and we can create controls the way we will see in this presentation. We can go from super easy to super complex. We will see mainly 2 ways. One way is called compound controls. Basically, it's grouping different views like we do with an existing layout, like linear layout, like constraint layout, or any other view group that we want. And basically, what we are doing with this is encapsulating everything, providing a nice interface, allowing other developers to reuse it. And well, we could also go in between, which is customizing existing controls by subclassing them. We will not see this one. And it's not here, sorry. And we will see how to do full custom controls by using completely custom drawing and using Canvas. We can use these techniques in many use cases, as I was saying. When we don't have a similar control in the system, when we are reusing a given set of views, for example, to create a single unit, which repeats in many places in the app. Or, for example, if theming is not enough. And, well, there are a few benefits on all this. One is to encapsulate and simplify common controls. With this, we can create a design language. We can simplify maintenance. Everything would be cleaner because we are encapsulating everything and we are allowing to reuse. Basically, we can use it to move certain logic which is only related to the control outside of the activity, for example, and inside the control, so everything is together. All the related operations of the control are in a single place, and what we expose is a common interface to the outside, so we don't have to think on the details of what we are doing. We want to, for example, enable a given functionality, and this can mean change a color, disable a control, and set a default value. We can do it with this, and what we expose is simply a method or an accessor to use this functionality. So, compound controls. So basically, what we do with these controls is to extend a given view group. For example, as I was saying, linear layout, constraint layout. We inflate this layout, we attach it to the control, and profit. So what we do with this? This is an example. We are creating a class, my compound control view, with a constructor. That's a small tip, which is using JVM overloads in Kotlin. So we don't need to implement all 4 constructors that we need to implement a control. With this, Kotlin takes care of all this. We use default values for the parameters, and then Kotlin creates all 4 constructors. So it creates a constructor that accepts a context. It creates accepts a context and uses the 3 default values. It creates another constructor that accepts context and the attribute set, etc. And during initialization, what we do is we inflate the control. We give the layout ID, and we attach it to this, which is the control we are creating. This would be an example of a layout. So simple control that it's using linear layout, vertical, 2 text views, and with this we can encapsulate, for example, a common pattern which would be title and subtitle. So what we get with this? Basically what we get is, if we check the view hierarchy, what we get is our control, then inside we get the linear layout with the 2 views that we were inflating. This is simple, it works, it's nice, so no problem with this. We can do it better. So if instead of using directly the linear layout in this example, we use the merge tag, notice that basically this my compound control view, it's a linear layout which contains a linear layout, in fact, because our compound control view subclasses from a linear layout. So we have 2 linear layouts, one inside of another. With merge, basically what we are doing is we are getting rid of this intermediary view group, and there are a few things we have to do. In this case, basically what we are doing is we are changing all Android semicolon to tool semicolon. This is to be able to use the preview, so we are able to see the result. But the problem is that then we need to, for example, in this case, we need to add this orientation in the initialization, because basically this merge is not merging these attributes into our view. Basically, our view is our view group, or linear layout in this case is this, and we need to set manually these properties. Another small detail is that we are using tool parent tag. Basically, is to tell the editor that this would be rendered inside a linear layout. If we don't do it like this, the preview would be wrong. And for example, in this case, I think it uses by default, it renders like it would be a frame layout, I think, or something like this. So basically, this will allow us to get rid of this extra view group, but keep all the goodies of the preview. And what we get is this, basically. We get rid of the linear layout, which we already had, and it's a flatter hierarchy. So it's good for performance reasons. If we have to do it many times, we will save quite a few resources. Then, how do we use this control? Basically, like we use any other control. The only detail here is that we need to specify the full qualified name. We are already doing this for example, for constraint layout in this example, so it's nothing that we are not used to, but we need to just remember this. Okay, so that would be custom controls. Let me switch to, because I didn't have that much time to prepare everything. Basically, the whole control, well, in this example, would look like this. And basically, we would have to add some properties here if we want to expose functionality outside. In this case, we could do something simple like set title. This is not very idiomatic, but yeah? Sorry. Yes. Where is it? This one. Okay. So in this case, first of all, we need to. This would be quick and dirty. That would be, for example, title. This is a text view. It's not. Well, let's do it with subtitle. I don't know. Maybe I created it with another name. Sorry, that would be by lazy. Okay. And then we just need to use this. we are not exposing it outside. So in this case, text, well, that's wrong. Oh, yeah, okay. Well, so basically what we are doing is something quite simple, which is exposing what we want to expose to the outside. We can use methods, we can use properties, whatever it works for the control. And with this, we are able to just expose the functionality we want for this control. Okay. Okay, so this is the simple way to create custom controls. And then now we will see how to create, sorry, this was compound controls. Now we will go to how to create custom controls, so fully customized controls. And first thing we need to know is how the UI drawing works in Android. Of course, what we are using is the traditional, let's say, Android UI. We are not going to see anything like Jetpack Compose or anything like this. Basically, drawing works, first of all, by measuring. We measure every view in the hierarchy, and the layouts will measure the sub-views inside of it. And with all this information, we lay out what will be drawn in the screen. And then we draw. In this case, we will use Canvas to draw. What we are interested in is in the measure and in the draw steps. The layout step would be for view groups, and we will not be seeing this. But basically, view groups, usually what they do is they measure all the child views, then they layout it. Maybe they have to draw, for example, if there is a background. But the more important steps are measure and layout. For custom control, basically measure and draw. So, measuring. Basically, we will get a non-measure call. We have to overload this method. We have to derive from a view or maybe from other view we want to subclass, and we implement on measure. For every, so we get two parameters. For every axis, we get two measure specs. Measure spec is together, it contains a size and a mode. Basically, mode can have three values: unspecified, exactly, or at most. Exactly, it means that we set this dimension with a specific size. So, for example, if we set width to 20 dps, for example. Unspecified usually is when we use wrap content. So we allow the view to choose whatever size it wants, and at most it sets a maximum dimension. So it's a bit cut. So basically, what we do in the onMeasure is we calculate the dimension we want to have for every axis, and then we use resolve size and state, which is a method that is in the view in the view class. And basically what it does is it takes the size we want to have, it takes the measure spec, and it takes an extra parameter that for views is basically not used. we can set it to 0, and it reconciliates all this. No? If we have a maximum dimension, for example, with at most, and the dimension we try to use is bigger, it will set this maximum, and it will set a flag saying there is not enough room, but it's fine. So the view will be constrained by the maximum dimension. If we set another dimension and it's within the allowed size, it will return this dimension. If we set an exact size, then it will return this exact size. We can do this manually. We can use these two methods, measure spec get mode and measure spec get size, to get the mode and the size and do it manually. But usually, with this resolve size and state, it's enough. We could choose to not use it if we need to have some special rules, like if given dimension it doesn't fit, then we constrain the other dimension, special cases like this. But usually with this is enough. When we have the width and height with these constraints applied, an important step is to set measure dimension. That's another method from the view, and we have to call it. If we forget to call it, we will get an exception and nothing will work. So basically we have to measure and then set measure dimension to tell the view that that would be the resolved dimensions. Important details. Units are pixels. So we are not getting DPs, we are not getting anything else, we are getting pixels. Basically, what we have to do is to use whatever dimension we need to use and convert it to pixels always. For example, if we are getting the dimensions from the layout, they would be already in pixels. So this is fine. What I said, we must call set measure dimension. If not, we will get an exception. And we can use resolve size and state as a helper to help us doing all this. So with this, we have a control that has a size, but is still not drawn. So then what we use is canvas to draw. We will get an onDraw call, and this onDraw call will get a canvas. Again, units are pixels. Top left is 0, 0. So it's not mathematical axis, it's computer axes. And another important thing is draw commands are run one after another, and basically it's like we are painting in a canvas. So if we, for example, draw a square and then we draw a circle, the circle will be drawn on top of the square. Another concept we'll see now, it's paint. So canvas is where things are drawn. It can have a backing bitmap, so we can draw to the screen, so to speak, which is the use case we will see, or we could give it a bitmap, create a canvas with a bitmap, so we can draw in this bitmap and, for example, render something off screen. Paint is how things are drawn. Basically, the parameters are set in Paint. One important detail here is that we have to set up everything before the onDrawn happens. We will see it in the example. But basically, all the expensive stuff must be done before the onDraw phase. That's because we know there are 16 milliseconds if we are running at 60 Hertz. If we have something faster in the future or whatever, it would be less. So we have to be fast. Another important detail is usually it's better to not allocate memory during the on-draw. It's better to pre-allocate everything, prepare everything beforehand, and then we can draw. And the baking bitmap. So, well, few canvas commands, draw bitmap. It will allow us to draw a bitmap, draw rect, draw cycle, to draw different primitives. Now we will see an example. Draw color will fill the canvas with a given color. Draw text to draw a string of text. Remember, all this needs a paint with all the parameters, so everything should be ready before using this. And another important detail is to be able to use clip. So basically, clip is is a set of commands that allow us to clip what we are drawing in the screen, in the canvas. So with this, by default, the canvas is constrained, so we are drawing inside this canvas. We are not allowed to draw outside, usually. But we can constrain it even further. So we can set a path with a certain figure and then fill it with a single color, and what we will get is this path clipping and a filled color. So it would be like we are drawing this path field. Well, Canvas and KTX. Let's go and see. Before going into Canvas and KTX, let's go and see an example. The other side. So, basically, that would be a custom view. Same structure, but same structure like with the compound control. So we are creating a control. We use JVM overloads to have all the constructors, but in this case, we are extending a view instead of another view group. In the initialization, in this example, basically what I'm doing is I'm getting a few default values. For example, if this control is centered, a given color, a disabled color, an orientation in this case, which we will not use it for this example, is just to showcase that we can use Android default properties, and the radius. So this control, this example would be a circle with a color, something super simple. KTX, in this example, we are using KTX. We'll see how to include it later, but in this case, I'm using with styled attributes to get a stylable that I have defined. Let me show you up. I lost it. So this would be my stylable, and here I'm declaring all the different parameters that all the different attributes that I can use in my layout definition. Notice that I can set a format. So in this case, I'm saying that centered is a Boolean, color, it's a color, disabled color, it's a color too, and radius is a dimension. This one is nice because with this, for example, I can set a dimension with the units I choose, and will get converted automatically. And here I have the default values. So what I'm doing here is I'm doing a type array, which is this in this case, get Boolean, and the different attributes that I have. So I'm basically initializing my the state of my control. And here I have defined all the different parameters as properties. So from outside the control, I can manipulate these properties. Two things that are worth noting. First of all, when I set a value, I have to invalidate the control. This step is important because when I set a value, the control will not get redrawn unless I invalidate it. There is a way to invalidate just a region of a given control, but Google is not recommending it anymore from a given version of Android. Basically, invalidate with a rect. What it does is just calls invalidate without any option, because Google realized that this optimization was not really an optimization. So they switched to just recommending invalidate for all the cases. So when I change the center, I have to invalidate. I save the value and I invalidate the parameter. This other example, when I set the color, basically what I'm doing is I'm using my paint and setting the parameter into my paint. The paint is defined here. Basically, as I said, you set everything from outside the on-draw. You prepare everything, and in this case, this paint is the one that defines that the style will be filled, and the color is defined here. So I set paint.color to the value I want to use. Same here. When I initialize my control from attributes, so from the layout, I set paint.color, get color, blah, blah, blah. So with this, I'm setting the values I want to use. So in this case, I set the color and then invalidate to trigger a redrawn. There is another case that I set it here as an example, but we are not using in this control. In this case, would be if I change the orientation. If I change the orientation, I would like my control to re-layout. So instead of just redrawing, do the whole process. So measure, layout, and draw. This example would be this one, request layout. So in the orientation, if I get a new value, I'm getting an integer. I check it if it's a valid value, horizontal or vertical. I save it, and I request a layout. So that would be the different properties of the layout, of the control. Then let's go to the meat. On measure, basically we have already seen it in the slides. Another thing, a thing that I haven't mentioned in the slides is that we need to take into account the padding. So we don't need to take into account margin, but we need to take into account padding for the control. So basically the control is responsible of drawing everything that is inside its bounds. Margin is outside, we don't care. Padding is inside, so we need to take into account. So for this, for the width, basically I'm taking into account padding start and padding end, plus the dimension I would like for my control to have. In this case is radius times 2, so to have the diameter, and I'm resolving size and state, and same for the height. So taking into account top and bottom and radius. And then drawing. So when we get to the drawing, basically what we are doing here is we are calculating the parameters. We could even optimize this a little bit. We could take this calculation outside, but in this case, we are not doing any memory allocation or anything that could trigger the garbage collector. So we are doing the calculation here. It's cheap, so it's fine to have it in the in the onDraw in this case. We calculate all the parameters. We are calling super.onDraw in this case. So if there is something we want to use from the default view implementation, in this example, I would be using the background. We get it for free. Basically, what we are doing is we are calling onDraw first in this example, because we allow the view to draw whatever it needs to draw, and then we draw on top the circle. In this case, what I'm using is canvas.apply to have canvas inside. And this is KTX with translation. Basically, when I'm using canvas, I can use draw commands, but I also can use operations like translation, scaling, rotation, using matrices to do all this, for example, perspective or similar stuff. And KTX, basically, what it's doing is making my code a bit cleaner in this case. This example is a bit like forced, because what I'm doing is, instead of adding the padding start and padding top here, what I'm doing is I'm using translation. So this example is a bit forced, but it allows us to showcase this. Basically, this code without KTX, we will need to do a canvas.save to save the state of the canvas. We will need to call translate, same parameters like as in with translation, then draw my circle, and finally restore. And I could have these operations nested, so it can get more complicated. So in this example, simple example, we don't really see the power of KTX, but if we have something more complex that needs to translate, then rotate, this save and restore gets more complicated, code gets dirtier, so it's better in these more complex examples. And then basically what I'm doing is canvas.drawCircle. In this case, parameters are center, radius, and finally what I'm providing is a paint. So as I said, paint will allow us to provide the parameters on how to draw. And in this case, if the control is enabled, what I'm doing is I'm using the one, maybe I should have called it enable paint and disable paint, would be clearer. But I'm using the paint with the color for the enable case. And if not, I'm using the disable paint in this case, which is the other paint. And I'm using this to draw the circle. So basically that would be this simple example. And if we, if I think it's activity main, yeah. If we see the the usage of all these two controls, compound control, basically it's the one that we already seen it in the slides. And the custom control, in this case, I'm showing two examples, wrap content with a default radius, which is set to 30 dps, I think. I'm using the constraint layout parameters. These parameters are for the layout, so the view will not use these parameters. Setting a padding and setting a background color. In this case, I'm using hollow blue. Sorry, I'm a developer. And in this other example, what I'm doing is I'm setting a 50 dps radius, but a 60 dps width. So in this case, width is smaller than the desired one, and we will see that it gets clipped. And a padding top also. So let's see this in action. I think this was already. Okay, this was fast. Basically, haven't changed the example. So in this case, I'm not sure if you can clearly see what's going on here. So first of all, compound control, title and subtitle. This is quite easy. Then my custom control. First example, it has a padding top, so we can see that we are taking this constraint into account, and it's wrapping both dimensions plus the padding. We are getting this circle that it's in the bottom of the containing box. As I said, first of all, I'm calling the super.onDraw. This would take care of drawing the background in this example, and then I'm drawing the circle, the red circle. Second example, different background, but also blue one, and with the constraint dimension, so the circle is clipped in this case. So in this case, what we are seeing is that the constraints are applied during the onMeasure, and we are setting it as it should. So, okay, well, remaining stuff. To use KTX, in this case, it's in the core KTX dependency. Well, it helps to clean up code, as we already seen. We have with clip, so we can set clipping with matrix, with rotation, etc. And basically, here is the reference of the different operations we can use. I will share the slides. And, well, that's it. So, questions?
Is there any kind of tool that will allow you to have a preview while you are doing the on-draw and all that, or you just have to run the emulator and see what you get?
Usually this is tricky you should be able to see the preview, yeah. But usually what you get is, so in the case of compound controls, you see it, but in the case we are seeing, well, yeah, sometimes it fails, sometimes it works, but in this case it's working.
If I'm not wrong, I think that you have to recompile everything that you change something, because if not, you don't see it.
Yeah.
And how difficult would it be if you want to make the red thing clickable but not the blue one?
Well,
I mean, if I make something super custom, super
yeah.
cool, and I want to make the red thing clickable but not the blue one.
Basically, in this case, you have to override the onTouch events, and in this case, you should test the point with the, in this case, if it's a circle, what I would do is distance from the center compared with the radius, taking into account the units and everything, but that would be how I would do it in this case. That would be a whole topic by itself, because on touch and everything, yeah. Yeah, no, you're right. You're right.
I was just wondering how
Yeah. More questions?
Yeah, so one of the use cases that some time ago I used this canvas thingy and all of this, it was to make like a screenshot of the of what you are rendering. So you can like use it before the bitmap, and then you copy the canvas and all that. But I don't know why, I don't know if anyone knows why the shadows are not drawn into the bitmap version, but yes. I think it's something related with outline or...
Yes, in this case, well, I haven't run into this case, but I would say it's because of the online. Because the outline is calculated after you draw. You can set it manually also, but it's calculated after you draw, and then the system, so after Lollipop takes care of all this. With the outline, which is a path, it creates the shadows. So in this case, probably that's the problem, because what you are drawing is everything else, and the system is taking care of the shadows. Yeah, because what we haven't seen is that all this, basically, all this is on I think it was from Lollipop, or no, from Marshmallow, I think, or KitKat. I don't remember the exact version, but Android switched to hardware layers, and by default, no, it was probably Honeycomb. Yeah, I think so. Basically, it uses hardware layers in order to speed up all this. It uses Skia, which is the rendering engine behind Google Chrome 2 and Flutter also. So it's quite nice, quite fast. Sometimes you can run into some issues if you are trying to use some weird combinations and stuff, and then maybe for some cases you have to switch back to software rendering, but I haven't run into any case like this with all the controls I have done in the past. And these hardware layers allows the system to also take into account the Z, the dip used for material. It allows to use to create the shadows and all the stuff. So basically, the layered approach, so painting on top of previous things you have drawn, is something we can take for granted in the canvas itself, but not with other elements in the same layout, because other elements can be in a different layer on top of the layer we are drawing or anything. So that would be it. So in this case, most likely it's because of the outline and the system setting it manually. Calculating it automatically. More questions? Okay. So if you think of something, I will be around. That's it. Thanks for coming. By the way, I will share the slides later and the code. So if you want to use it, I will share it in the group. Thank you.